In this video, we're going to look at factoring by grouping. In our examples, we'll be looking at polynomials with 4 terms, and we will group these into 2 pairs. So we'll group the first 2 terms and the second 2 terms. It is possible in some cases that you'll have to change the order of the terms to get a different grouping, but I recommend starting with the order that they're given. The first step is to factor out the greatest common factor from each group separately. So if we look at the first pair, what is the greatest common factor of these 2 terms? You can see that we have a common factor of 5 between the 2 coefficients, and we also have x with the variables. So we're going to factor out a 5x from these 2 terms. We know we need 2 terms inside the parentheses to match the original 2 terms. When we distribute this 5x, what do we need to multiply by in the first term to get a 5ax? We need to multiply by a. Notice that's the only factor left after you factor out the 5 and the x. When we distribute the 5x to the second term, what do we need to multiply by to get a 10x? We'll need to multiply 5x times 2. And this is positive because we want a positive 10x. So we factored out the greatest common factor from the first 2 terms, and now we'll do the same thing with the second 2 terms. You can see that we have a common factor of 3 between these coefficients, and there is no variable on the second term here, so the greatest common factor will be 3. Make sure you put the plus here. We were factoring out a positive 3. If we were factoring out a negative 3, then this would be a minus for subtraction. Remember, when you distribute this 3 into the parentheses, you need to get these 2 separate terms. So they all have to be separated by either addition or subtraction. And if you leave out this plus sign, then you would just have multiplication all the way across, and you'd get something very different. When we think of distributing the 3 into the parentheses, on the first term, what do we need to multiply by to get 3a? That'll have to be a. And what do we need to multiply by in the second term to get a positive 6? That'll be positive 2. So we've factored out the GCF now from both pairs of terms. And again, you should always check these by distributing. 3 times a is 3a, 3 times 2 is 6, 5x times a is 5ax, and 5x times 2 is 10x. So this expression is equal to the one that we started with. Now, in order for us to be able to continue factoring this, the expression inside each set of parentheses must be exactly the same. If these expressions are not the same, then we will not be able to factor by grouping with the order that these terms are given. So then we can try changing the order of 2 of the terms and grouping these into 2 different pairs. If no combination works out so that you get the same expression inside the parentheses, then this is not factorable by grouping. Now let's look at how we'll complete this when we do have the same expression inside. First, let me rewrite this and use a single variable to represent the expression a plus 2. We'll use a y here in place of the a plus 2. So this expression has the same form as the one we have down here, but it might be easier to see in this form that we have a common factor of y, and we can factor that out. So we're factoring out this common factor of y. When we distribute, y times the first term has to equal 5xy. So that means we need the 5x in the first term. You can see those are the 2 factors left after we factor out the y. And then y times the second term has to equal positive 3y. So the second term has to equal positive 3. This is a fairly simple example of factoring out a common factor. We'll be doing the exact same thing down here, except that the y will be equal to the expression a plus 2. So here we'll be factoring out this common factor of a plus 2. And if we look at distributing this a plus 2 as a single unit, this whole expression times the first term needs to equal 5x times a plus 2. That means we need the 5x here in the first term. And then distributing this expression as a single unit to the second term, we need to get 3 times a plus 2. So the second term needs to be positive 3. And now we have the original polynomial factored. If you multiply this out using distribution or FOIL, you will get this polynomial that we started with. For your final answer, it won't matter what order these factors are in. The most important thing for understanding grouping is understanding this last step, how we're factoring out this a plus 2 as a common factor, and how this is exactly the same thing as factoring out the y in this expression up here. We're doing the exact same thing, but in this form it looks a little more complicated, and students can have trouble understanding how we complete this last step. Let's look at another example. Here's another polynomial with 4 terms. Let's start by grouping them into the pairs formed by the first 2 terms and the second 2 terms. In the first pair, or the first group, we do have a common factor of 3 between these coefficients, and we have no common factors with the variables. So the greatest common factor of these 2 terms is 3. And we want to factor this out. 3 times the first term has to equal 15x squared. So we need a 5x squared. And 3 times the second term is equal to negative 12y. So we need the second term to be negative 4y. Remember, you can divide the original terms by the greatest common factor to get the terms inside the parentheses here. 15x squared divided by 3 is 5x squared, and negative 12y divided by 3 is negative 4y. But you should double check these with distribution to make sure that you get the original terms back. In the second pair, the coefficients 20 and 9 do not have a common factor. We do get a common factor with the variable x. So we'll factor out an x. X times the first term equals 20xy. So the first term will be 20y. And x times the second term will equal negative 9x. So the second term is negative 9. So that gives us 20xy minus 9x. And again, it's very important that you put an addition sign here if you're factoring out a positive factor from these 2 terms, or a subtraction sign if you're factoring out a negative factor. Notice here that the expressions inside the parentheses are not equal. So we won't be able to continue factoring this with the grouping that we've used, because we will only be able to factor this out as a common factor if these expressions are equal. So let's try changing the order on these terms and get a different grouping. You can look at different pairs to see what kind of common factors you can get. The 15x squared and the 20xy have a common factor of 5 and x. The negative 12y and the negative 9x have a common factor of 3. But you could also try grouping the 15x squared with the negative 9x and the negative 12y with the 20xy. Let's go ahead and just change the order on the 2 middle terms. That way we'll group the 15x squared and the 20xy and the negative 12y and the negative 9x. Remember that each term has to have the same positive or negative that it had in the original expression. So I'm treating this as a negative 12y and this as a positive 20xy, and we're just changing the order. So here we have our grouping of 2 pairs. In the first group, we have a common factor of 5 and a common factor of x. So the greatest common factor will be 5x. 5x times the first term is 15x squared, so we need a 3x. And 5x times the second term is positive 20xy, so we need a positive 4y. If you prefer division, 15x squared divided by 5x is equal to 3x, and 20xy divided by 5x is equal to 4y. Now in the second pair, or the second group, we have a common factor of 3. Since these are both negative, and we know that we want positive terms inside the parentheses, we'll need to factor out a negative 3. Negative 3 times the first term is equal to negative 12y, so the first term is 4y. And negative 3 times the second term is negative 9x, so the second term is positive 3x. Negative 3 times 4y is negative 12y, and negative 3 times 3x is negative 9x. Now we have expressions inside the parentheses that are in the opposite order, but the two terms are identical. They're both positive 3x and positive 4y. So we can change the order in either of these, and it won't change the expression. Now we have this common factor, 3x plus 4y, and we're going to factor this out as a single unit. If we think of distributing this as a whole unit, this times the first term has to equal 5x times this expression. So we need a 5x in the first term. And this expression times the second term will equal negative 3 times the expression. It's not difficult to see where the 5x and the minus 3 are coming from the previous line. So here, again, we factored the polynomial that we started with. And the order of these two factors doesn't matter. Either of these would be fine for the final answer. Some people look at this line and want to put the 5x minus 3 first, and then the 3x plus 4y second. But I usually explain this as factoring out this expression as a common factor, and we usually write the common factor in front when we factor it out. But these are equal, and you can double check your answer in either case by multiplying this out using FOIL and seeing if you get your original polynomial. Let's look at another example. Here's another polynomial with 4 terms, and we have this grouped into the first pair and the second pair. Let's factor out the greatest common factor from the first pair. We have no common factor between the coefficients 3 and 4, but we do have a common factor with the variable y. It's not difficult to see when we factor out the y, we're going to be left with 3x minus 4u. On the second pair, we have a common factor of 2 between the coefficients 6 and 8, and we also have a common factor of v from the variables. So our greatest common factor is 2 times v. Now let's suppose that we weren't thinking about the positive or negatives yet, and we just factored out a positive 2v. In this case, when we distribute and multiply by the first term, we have to get negative 6xv. Since this is a positive 2v in front, we would have to have a negative 3x inside. And then 2v times positive 4u will equal positive 8uv. Now, inside the parentheses, we have a 3x minus 4u and a negative 3x plus 4u. These are exact opposites because each of the terms has the opposite sign, a negative 3x instead of a positive 3x, and a positive 4u instead of a negative 4u. These expressions are not the same, so we cannot continue factoring the way it's written now. But we don't have to change the order on any of the terms. When you have opposite expressions inside the parentheses, that means that you can factor a negative out of one of them. And the easiest way to do this is to go back to the second pair and factor out a GCF with the opposite sign. So instead of factoring out a positive 2v, we'll factor out a negative 2v. Now negative 2v times the first term is equal to negative 6xv. So the first term will now be positive 3x. Negative 2v times positive 3x is negative 6xv. When we distribute to the second term, negative 2v times the second term is equal to positive 8uv. So we need a double negative, and the second term will have to be negative 4u. Negative 2v times negative 4u is positive 8uv. Anytime you factor out a negative, the terms inside the parentheses will have the opposite signs of the terms that you started with. Notice now the expressions are identical. So now we can continue factoring this. We're treating 3x minus 4u as a single factor, and we're factoring that out. What's left inside the parentheses will be the numbers that were in front of these expressions. So we'll have y for the first term and minus 2v for the second term. And again, the order for these factors does not matter. And you can double check your answer by multiplying this out using FOIL. Remember, if you cannot get the same expression inside the parentheses here, then the grouping that you're using won't work, and you'll have to try changing the order to get a different grouping. If you've tried all the possible groupings and none of them give you the same expression inside the parentheses, then you can state that the polynomial is not factorable.